Hello everyone and welcome back to our channel. In today's video, we are going to explore the drop function in PySpark, a simple yet effective tool for managing your data frames. Whether you need to clean up unnecessary columns or simplify your data for analysis, drop is your go-to function for removing columns quickly and efficiently. I'll show you how to use it to keep your data frames clean, organized and easy to work with. If you're ready to learn more about how to drop columns like a pro, then let's get started. Introduction to the drop function. The drop function in PySpark is a simple yet powerful tool that allows you to remove one or more columns from a data frame. This function is especially useful when you need to clean up your data by eliminating columns that are no longer needed for your analysis or processing. Often datasets contain extra information that may not be relevant to your specific task, and removing these columns can help you streamline the data frame, making it more efficient to work with. The drop function helps improve the readability of your data frame by keeping only the columns that matter most to your analysis, thus reducing complexity and memory usage. It is straightforward to use and can accept multiple column names as arguments, giving you the flexibility to remove a single column or several at once. Whether you need to simplify your dataset, optimize performance, or just focus on specific data points, the drop function is a valuable tool that helps you keep your data frame organized and easy to manage. Basic syntax. The basic syntax for using the drop function in PySpark is dataframe.drop calls. In this syntax, the calls parameter represents the column or columns that you want to remove from the data frame. You can specify one or more column names as strings, and if you need to drop multiple columns, you can simply provide their names separated by commas. The star before calls allows you to pass multiple arguments, which makes it easy to drop several columns in a single call. For example, if you have columns that are redundant, irrelevant, or not needed for the next steps in your analysis, you can use drop to eliminate them and make your data frame more manageable. By removing unnecessary columns, you can focus on the data that is essential for your analysis, ultimately reducing complexity and improving performance. The ability to quickly drop one or more columns helps keep your data frame clean and organized, making it easier to work with and ensuring that you only retain the data that is useful for your specific task. How it works. When you call the drop function in PySpark, it returns an data frame with the specified columns removed while leaving the original data frame unchanged. This means that drop operates in a properties in a non-destructive manner, allowing you to make changes without affecting your original region unless you explicitly choose to reassign the modified data frame. This is particularly useful when you need to experiment with dropping columns but want to retain the original structure of the data for other purposes or backup. If you need to drop multiple columns, you can simply pass the column names as arguments separated by commas. This allows you to remove several columns at once, making the code more concise and efficient compared to dropping columns one at a time. The ability to drop multiple columns in a single operation saves time and helps simplify your code, especially when dealing with large datasets that may contain many irrelevant columns. Overall, drop is a handy tool for cleaning and managing your data, ensuring that your data frame only contains the necessary information for your analysis. It helps keep your data focused and organized, providing a clear and efficient way to remove columns that are no longer needed. Practical examples. 1. Dropping a single column. In this example, we are working with a PySpark data frame div that contains employee information, including employee underscore aid, name, email, and salary. We create the data frame using the create data frame function and provide a list of tuples representing each employee's details. The columns represent the employee's unique ID, email address, and salary, providing a comprehensive view of each employee's data. To clean up the data frame and focus on only the most relevant columns, we use the drop function to remove the email column. The drop email function call creates a new data frame where the email column is no longer included. This can be useful when the email information is not necessary for the specific analysis you are performing, and removing it helps to simplify the data structure. Since drop returns a new data frame, the original data frame diff remains unchanged unless reassigned. Finally, we use the dot show method to display the resulting data frame, which now contains only the employee underscore id name and salary columns. By dropping the email column, we make the data frame more streamlined and focused on just the details that are important for further analysis. This approach is particularly helpful when you need to reduce the complexity of your data frame or eliminate unnecessary information, making your data easier to work with and more efficient to process. 2. Dropping multiple columns. In this example, we are working with a PySpark data frame div that contains employee information, including columns for employee underscore id, name, L, and salary. We create data frame using the created data frame function, where each row contains details about an employee such as unique D, name, email address, and salary. This structured data is useful for a wide range of analysis and transformations. To simplify the data frame, we use the drop function to remove multiple columns at once. Specifically, we call def.drop email salary to drop both the email and salary columns. The drop function allows us to pass multiple column names separated by commas, making it easy to remove more than one column in a single operation. This helps reduce redundancy and focus only on the most relevant information for the current analysis. In this example, we are left with just the employee underscore id and name columns, making the data frame simpler and easier to manage. Finally, we use the dot show method to display the updated data frame, which now contains only the employee underscore id and name columns. This approach is especially useful when you want to eliminate columns that are not required for a particular task, thereby reducing the size and complexity of your data. By dropping unnecessary columns, you make your data frame more efficient to work with and easier to navigate, which ultimately mitigates quality and speed or data processing workflow. 3. Handling non-existent columns. In this example, we are working with a PySpark data frame div that contains employee information, including employee underscore and name, email, and salary. We create the data frame using the create data frame function, which helps us organize the employee details into structured columns, making the data easy to analyze and manipulate. In the given code, we use the drop function to attempt to remove multiple columns, specifically address and email. However, the address column does not exist in the original data frame. Fortunately, PySpark's drop function is designed to handle such situations gracefully, simply ignores the non-existent column and proceeds without raising an error. In this case, even though address does not exist, the drop function will still successfully remove the email column. After executing the drop function, we use the .show method to display the resulting data frame, which contains the original columns minus the email column. The employee underscore id, name, and salary columns remain intact. This behavior is particularly helpful when you are not certain if a specific column exists in the data frame, as PySpark will ignore the missing column and continue to drop the others without interruption. It ensures that your data transformation operations remain resilient and do not fail due to non-existent column names, allowing you to streamline your workflow and manage your data effectively. 4. Dropping columns in a loop. In this example, we are working with a PySpark data frame div that contains employee information, including columns for employee underscore id, name, email, and salary. We start by creating the data frame using the create a data frame function, which helps us structure the employee data in an organized manner, making it easy to work with for further processing. To drop multiple columns dynamically, we first define a list called cols underscore to underscore drop, which contains the names of the columns that we want to remove, specifically email and salary. Instead of passing these column names directly to the drop function, we use a loop to iterate over the list of columns. This allows for more flexibility, especially when the columns to be dropped are determined at read time or based on certain conditions. In the loop, we iterate over each column name in calls underscore to underscore drop and call df.drop call to remove that column from the data frame. By reassigning diff each time we drop a column, we ensure that the changes are applied sequentially and the data frame is updated after each iteration. This approach is useful when you need to drop columns in a dynamic way, such as when the columns to be dropped are specified by user input or determined programmatically. After dropping the columns, we use the .show method to display the resulting data frame, which now contains only the employee underscore and name columns. This technique of dropping columns dynamically provides flexibility in managing your data frame, allowing you to customize the removal of columns as needed. It helps keep your data frame clean and focused on the data that is most relevant to your analysis, making it more efficient and easier to work with. 5. Dropping columns using a condition advanced. In this example, we are working with a PySpark data frame DF that contains employee information, including employee underscore ed, name, email, and salary. The data frame is created using the create data frame function, allowing us to structure employee details into organized columns for easy analysis and manipulation. The goal here is to drop all columns in the data frame that have a data type of string. To achieve this, we start by generating a list of column names that match the data to want to drop. We use a list comprehension to iterate over the column names and data types in df.dates, which returns a list of tuples where each tuple contains the name in its data type. By filtering for columns where the data type string, we create a list called string underscore post that contains the names of all columns with string data types, in this case name and email. Once we have the list of string columns, we use the drop function to remove them from the data frame. We pass the column names using the string underscore call syntax, which unpacks the list of column names as individual elements to the drop function. This allows us to drop all the specified string columns in one go, resulting in a new data frame that no longer contains those columns. Finally, we use the .show method to display the updated data frame, which now only contains the columns that are not of string data, specifically employee underscore id and salary. This approach is particularly useful when you need to clean up your data frame by removing columns based on their data type, making the resulting data frame more focused and tailored to your specific analysis needs. By dropping all columns with string data types, you ensure that only relevant numerical data is retained, which can be especially helpful for calculations or statistical analysis. Thanks for watching. I hope this video helped you understand how to use the drop function to manage and clean up your PySpark data frames. It's a handy tool for keeping your data organized and focused on what matters most. If you enjoyed this video, please give it a thumbs up and don't forget to subscribe to our channel for more PySpark tutorials. If you have any questions or suggestions for future topics, feel free to leave them in the comments below. Until next time, keep exploring, keep coding, and make your data work for you.